Welcome to the U Classroom course training videos presented by UBTech's U Academy. The course here is called AI City Guardian, and it consists of 4 parts: a course overview, an introduction to the uGot hardware components, an introduction to the associated applications, and a demonstration class. Let's start with some basic information about this course. It aims to prepare students for real-life challenges, such as building collapses, missing children, ecological rescue, and materials dispatch. We have also created various virtual story scenarios, including emergency rescue in ruins, searching for people in a crowd, ecological protection, and mission accomplished. This course enables students to use artificial intelligence technologies like machine vision, machine learning, and intelligent speech to carry out different functions of the uGot robot. It can also help the city solve emergency problems and help students develop their problem-solving ability as well as their sense of social responsibility. This course follows the student-centered 5E teaching model. It aims to engage students and foster their curiosity. The uGot hardware devices used here are new, convenient to assemble and disassemble, and designed for effective problem solving and AI algorithm learning. It is recommended for students in years 5 and 6. There are 30 lessons and each one lasts 40 minutes. We have also incorporated the AI City Guardian kit, a props kit, and a map kit to facilitate classroom teaching. The program and software used is uCode. The course is designed according to international standards and guidelines such as A14, K12, and CSTA. It helps students better understand the scientific processes, methods, concepts, and principles, enabling them to cultivate a better attitude towards science and life. These 30 lessons meet the learning needs of students for one academic year and are divided into 4 units, with 14 general topics and 1 activity topic. The course material is also graded according to the level of difficulty. Unit 1 is titled Emergency Rescue in Ruins, and it has 4 topics: having a try, climbing over obstacles, finding people by sound, and joint rescue. In this unit, we will be using the transforming car and the mechanical arm. Having a try is our first introduction to the uGot robot. Students will learn about the functions and the basic operations of uGot. Climbing over obstacles covers the principles of laser distance measurement and the motions of the transforming car. It guides students to overcome obstacles. Finding people by sound is about the principles of sound source localization, and we can obtain rescue information through voice recognition technology. Joint rescue teaches students to build a mechanical arm, and they can use it to handle heavy objects and rescue trapped people. Unit 2 is about how to control the Magnum wheel car to complete searching for people in a crowd. It consists of 4 topics: flexible movement, observant eyes, automatic patrol, and tracking and tracing. Flexible movement introduces the Magnum wheel car and its omnidirectional mobility. Observant eyes is about facial recognition technology and its use in searching for missing children. Automatic patrol teaches students the basic principle of single-track patrol. We can program uGot to automatically patrol unplanned routes in order to improve the search efficiency. Tracking and tracing explains how uGot tracks suspicious vehicles through the number plate tracking function. Unit 3 is titled Ecological Protection. Here, we mainly use the uGot transforming car. It has 3 topics: color localization, image confirmation, and smooth transportation. Color localization uses color recognition technology to determine the location of hazardous chemicals and provides voice prompts. Image confirmation uses custom model training to further confirm the identification of hazardous chemicals. Smooth transportation introduces the balance principle of gyroscopes and uses a gyroscope to maintain a steady and stable posture when transporting lost hazardous chemicals. Unit 4 is titled Rushing to Help Rescue, and we will be using the Magnum wheel car and mechanical arm. It consists of 3 topics: cargo sorting, safe driving, and accurate delivery. Cargo sorting uses a mechanical arm to accurately grasp and carry items through abrotag recognition technology. Safe driving introduces how uGot follows the traffic rules and travels safely by recognizing road traffic signs and traffic police hand signals. Accurate delivery ensures precision through abrotag code recognition technology and dual-track patrol technology. Finally, there is an activity class. After understanding the functions of uGot through the thematic modules, encourage students to discover other rescue scenarios and choose the appropriate uGot form and the correct AI technology to complete the rescue tasks independently. This course has many resources that teachers can use. The AI Smart Education platform integrates relevant course materials. It offers electronic course packages such as PowerPoint lesson slides, teachers' books, and demo programs. Students can also use electronic evaluation books and textbooks in class. The AI Training Center is provided for AI knowledge learning and assessment. It has the latest version of uGot programming software and the AI micro certifications for learning evaluation, making it easier for teachers to teach. The uGot software also provides 3D dynamic building graphics of the uGot robot. They can be used in different courses to help teachers plan and simplify the teaching tasks. Teachers can use them as needed. Next, we will learn about the hardware equipment used in this course. Let's start with a video and learn about uGot's forms and functions. From this, we can see that the multi-mimic robot uGot uses a new knob lock design. This allows for easy disassembly and reassembly to switch between 10 different forms. We will mainly use the transforming car, Magnum wheel car, and mechanical arm in this course. The uGot controller is a convenient, flexible, and handy open-source hardware component. It is compatible not only with Python programming, but also with uCode graphical programming software. It has a built-in microphone array, strip lights, a speaker, a Wi-Fi module, a Bluetooth module, and a 9-axis gyroscope. Its 2.4-inch LCD touch display also makes controlling and using uGot much easier. The controller has many extra ports, such as customized Type-C interfaces for connecting motors, servos, sensors, and other electronic components. USB 2.0 and 3.0 interfaces for cameras, and open-source interfaces for open-source sensors, Raspberry Pi, and other devices. It helps students to access and understand open-source devices. The battery can be powered by magnetic attachment. The uGot controller has 6 Type-C interfaces that can connect to different electronic components and assign ID numbers to connected devices automatically. The built-in 2.4-inch touchscreen clearly displays system information and program running status. The uGot main controller can store multiple sets of programs at the same time. These programs can be selected to run when needed, making it easier for students to use. The controller with an independent NPU can provide offline version computing power, gesture recognition, human posture recognition, text recognition, key face point acquisition, image recognition, deep machine learning, and automatic driving. The kit contains a lot of equipment parts, mainly high RPM motors, high torque servos, and related connectors, making it easy for students to build various robot models. Now, we will use the uGot transforming car to show you the building process of the uGot robot. Now that we have learned about uGot's hardware equipment, next, we will explore its related applications. The AI Smart Education Platform is a desktop application that helps K-12 teachers and students with UBTech AI robotics courses. It differentiates between the teachers and the students with different accounts. It provides teachers and students with a teaching center, online access to course content, AI practical training operations, AI teaching programming tools, 3D simulation tools, student and class management platforms, class cloud and community creation sharing, teaching results assessment, and report output. The aim is to simplify the teach, practice, test, access, and manage process and make it easier for teachers. This course will be combined with the AI Training Center of the AI Intelligent Education Platform and enable the students to experience and learn AI knowledge such as image recognition, voice recognition, facial recognition, machine learning. The practical experience will help students deepen their understanding of the principles of AI technology and enrich the teaching of the course. With uCode, it is possible to program the uGot robot graphically. uCode is a software that teaches AI through visual programming. It has many AI functions that make AI lessons easier and more enjoyable. By using building block programming, students can easily develop programs, connect hardware devices, and use rich AI capabilities for learning and practicing. On the left side of the uCode interface, there is a block code area for programming. The programming blocks include categories of events, control, operators, variables, functions, motion, sound and light, sensor, AI speech, AI vision, and so on. Students can find the programming blocks they need by switching between the block categories and dragging them to the programming area in the middle to start programming. On the right side of the uCode interface, there is a hardware connection display area. It precisely shows the information of the connected hardware components. Click Upload in the upper right corner to switch to upload mode to view the hardware area. Click Add Hardware and select uGot in local devices. You will see the uGot icon appear under Add Hardware. Next, click on the connection button next to it, and you can choose to connect via Wi-Fi, hotspot, or IP address. We will now choose the Wi-Fi connection. Make sure that your computer and the uGot robot are on the same Wi-Fi network. Then confirm that the name of the searched device is the same as the name of the uGot device that needs to be connected. Click to connect it. When the connection is successful, the connection button will turn green and a small gear will appear. Next, we will present the class Finding People by Sound to you. Hello everyone! In Unit 1 of the course AI City Guardian. This lesson includes 4 parts. First, let us review the unit story. A typhoon was heading towards X City. Several outbuildings collapsed after the typhoon, and individuals got trapped inside. uGot needs to overcome the obstacle, find trapped people by sound, and launch a rescue. However, the wind is getting stronger and the rescue mission has become more difficult. People's lives are at stake and we shall not give up. The uGot transforming car has learned how to automatically climb over obstacles to help rescue trapped people. The rescue team know people are trapped ahead, but they don't know where. They need help. uGot said it will help and find out where they were based on their sound. The main task of this lesson is for the uGot transforming car to find people who are trapped by following sounds, gather details, and provide help and support to rescue them. Do you know what problems uGot needs to solve in order to locate the trapped people through sound source localization and communicate with them? That's right, the first problem is how to implement sound source localization. Next, we need to enable the uGot transforming car to recognize and respond to speech. We'll now look at how we implement sound source localization. Watch this video on how sound travels through our ears and how we locate its source. How does the machine perform sound source localization? What are some real-life applications of this technology? Next, do you know how the robot in this video performs sound source localization? The main controller of the transforming car is similar to a brain with many built-in hardware components. The built-in microphone array can get sound information, just like the human ear. Next, the main controller processes the acquired sound information and can tell where the sound is coming from, front, rear, left, or right. Through analysis, we can find out the features of sound source localization of uGot. It can detect louder sounds than background noise and locate them from the front, rear, left, or right directions. After learning about sound source localization principles, let's see how the technology is used in practice. Underwater, submarines use sonar equipment to detect, classify, locate, and track targets by using sound wave propagation and reflection properties. If there's any problem with the power equipment, the operating sound source and vibration may change. The acoustic imager allows for quick troubleshooting and collects real-time data. It enhances both operation and maintenance efficiency. After understanding the principles, how do we achieve the desired function through programming? Let's first learn about the code blocks. Open the uCode programming software, connect to uGot, click on the AI speech category, and we can see the code blocks in the subcategory sound source localization. The code block sound source positioning turn on, close, controls whether to turn on the function. The second code block, when the control hears sounds from listens to the sound, determine the source location and returns this information. The code block get loudness of the sound in dB obtains the value of the sound loudness, and uGot will carry out the next step after determining the loudness of the sound. Click the triangle drop-down button in the code block direction of sound heard by the controller. You'll see 4 directions, front, rear, left, and right, which correspond to the 4 directions of the uGot transforming car. Once you've grasped the basic functions of the code blocks, please complete task 1. You need to program the uGot transforming car to locate the sound source and travel towards it. First, use the code block sound source positioning turn on to enable sound source localization. Next, please use the code block direction of sound heard by the controller to locate the sound source. When the uGot transforming car detects a sound in front of it, it moves forward. Use the code block transforming car forward to control its forward movement. When sound comes from behind uGot, it moves backwards. If sound comes from the left, it turns left, and if sound comes from the right, it turns right. Where there is a sound, uGot moves to it. As the transforming car needs to constantly detect the sound location, it needs repetitive execution code blocks. See the complete demo program in the figure. After completing task 1, please complete task 2. Implement sound source localization and stop after reaching the sound source location. Do you know how uGot judges if it has reached the sound source location? The loudness of the sound is related to the distance. Use the code block Get Loudness of the sound in dB to determine the distance from the sound source. Use the code block controller display prints to show the acquired sound loudness values. You can see the changes in sound on the screen. Next, use the code block Here Main Controller display to clear the display content. Next, use the program to obtain sound loudness values from the main controller display. Analyze the differences in sound volume values obtained at varying distances from the sound source. After testing, we found that as the uGot transforming car drew closer to the sound source, the monitor's sound volume increased. If uGot is closer to a sound source, the monitor's sound loudness value will be greater. This means that by using the code block compare, we can make a comparison judgment. If the acquirement sound loudness value is greater than or equal to -20, it indicates that the distance is very close. The -20 figure is just for reference and can be modified according to the actual measurement. Next, complete task 2. Enable the uGot transforming car to stop moving when it approaches the local of the sound source within a certain range. This is the demo program. Students can refer to it as needed. The uGot transforming car goes near the sound source. If it determines that the loudness of the sound is greater than or equal to -20, it indicates that the transforming car is close enough to the sound source location, and the transforming car stops. Upload the completed program for testing. Test it by clapping hands for the uGot transforming car to perform sound source localization. Next, do you know how the uGot transforming car recognizes and responds to the speech? Let's watch a video first. Tell us how the robot in this video recognizes and responds to the speech. Machines need advanced programming to understand and respond to human language during a conversation. This process has 3 main stages. The first is speech recognition. The machine recognizes and records the sound, pre-processes and performs feature extraction, then converts the speech into text, and performs natural language processing to extract the key information. And finally, synthesizes the textual information into a speech output to complete the speech recognition and response. Open the AI Training Center to try it out. Log into the web version of the AI Smart Education platform with your campus account and password. Click on AI Training Center. Select the AI training area. Find the natural language processing in the AI training projects, and follow the prompts to experience voice conversation. Do you know how voice recognition technology is used in our daily life? People often use their mobile phone voice assistant to complete tasks by giving commands. In the smart home field, we can turn on and off appliances by voice and even implement more complex command control. Next, let us go through the code blocks for speech recognition and voice response. In the category AI speech, you will find the code block controller enables speech monitoring, ASR. Turn this to start speech monitoring. During monitoring, the main controller light is lit in green. Each run lasts for 3 seconds. If the process times out, the listening stops. The listening content can be in Chinese or English. Run the code block controller hears. When the matching field is recognized, return true, otherwise return false. To determine whether the specified text content has been heard, the input box allows up to 20 characters and supports both Chinese and English. The code block voice content heard by the controller converts the recognized results into text characters when speech monitoring is on. The code block controller plays voice allows the input text to be played as speech. It allows the machine to read out the input text when making a voice response. The code block controller plays voice until the end is similar to the code block controller plays voice. It plays the input text voice till the end, while the code block controller plays voice requires an extra waiting time code block. Therefore, we shall not use code block's controller plays voice and repeat together. This will cause incomplete input content playback and server crashes. Instead, the code block's controller plays voice until the end and repeat enable the input content to be fully played before the loop is executed, which is more appropriate. Now, let's move on to task 3. Trigger uGot sound source localization through a speech and initiate a conversation with the trapped people. To better understand the program's logic, refer to the flowchart. First, the uGot transforming car shall turn on speech monitoring. If it hears help, locate sound source and initiate a conversation. If not, continue to monitor speeches in a loop. Now, let's write the trigger condition for sound source localization. Activate speech monitoring to detect help. You can use these 3 code blocks for programming based on the original program. Try it yourself. Some of you may have completed the task, but if not, you can refer to the demo program. Begin by speech monitoring to identify the word help. If detected, activate the sound source localization directly. The next part is about voice conversation. We can use the code block join character to join 2 strings for voice broadcast. After arriving at the sound source location, start by playing the phrase, "What's your name?" Then review what the controller hears. Convert the name to text and reply with the phrase ABC. Wait a moment. We will be right there. ABC is the name of the person. Add the voice conversation program segment directly after the code block uGot transforming car stops, and add the code block break loop so that the uGot transforming car will stop repetition and break the loop once it finishes its task. After the speech monitoring is turned on, the main controller will light up green for 3 seconds. Talk after the green light is on when testing the code. In this way, the controller can get accurate information. Students who have completed the program can upload it to uGot and run for testing. When the uGot transforming car heard the voice of help, it followed the source of the voice and asked, "What's your name?" After hearing the answer, "My name is Yuko," uGot replies, "Yuko, wait a moment. We'll be right there." This completes the task of finding people by sound. Enhance your program by adding more engaging interactions. Please create a conversation that will occur when the uGot transforming car reaches the location of the trapped people. This is the demo program. You can refer to it or unleash your imagination to complete your own program. Finally, let's review this lesson. The lesson topic is finding people by sound. We use the AI voice module, the code blocks compare, join string, break loop, and motion control code block to enable uGot to locate sound sources and provide voice responses. Please showcase your creations from this lesson and share your approach. What challenges did you face? How did you overcome them? What new knowledge did you gain from the course? Alright, class is over. See you next time.